Now, under this reasons review unit 2, proving properties of parallelograms, I have done the seventh problem earlier, the seventh one. The seventh and this eighth are same type. Do this eighth exactly like seventh one in the previous video. Now we are after, so 7 and 8 same type, and we are proceeding to 11. 9 and 10 are missing those numbers here, so don't worry about those numbers. Let's go for 11th one. What is it saying? In the diagram of parallelogram ABCD, BE, this BE is perpendicular to CED line. That means here it is 90. DF perpendicular to BFC. This DF perpendicular to this BFC. That means this is also 90 degrees here. And CE is congruent to CF. That means this CE and this CF, they are equal sides. That's what it is given. What is he asking? To prove ABCD is a rhombus. So to prove this, what we do, we take we do two column proof. I am drawing line here and I am calling the left side statements in the same way, right side reasons. Statements, and here reasons. So how do we prove this? First statement, my strategy is to prove ABCD rhombus. I prove this BC side and DC side are equal, adjacent side. It's already a parallelogram. In a parallelogram, opposite sides only equal, not adjacent side. This side is not equal to this side in a parallelogram. But in the case of a rhombus, these two are also equal. I mean, all the four sides must be equal in a rhombus. That means if we prove BC and DC, our problem is over. To prove BC and DC equal, first I prove this BEC triangle congruent to this DFC triangle. See, one is the red triangle, another is black triangle. Now I want to prove these two triangles congruent. When once I prove these two triangles congruent, automatically BC and this DC will be congruent. Thereby we can conclude ABCD is a rhombus. For that, I give first statement like this. In this red triangle, I have CE is congruent to, that means this little side on which it is standing, and this CF, that is exactly equal to CF. This triangle, this black triangle is sitting on CF. So these two sides are equal. Who told us? This is given. You see, here it is given. That's why I written the reason as given. Next, second point. You see, the second point is this angle is 90 in this triangle. This angle is 90 in this black triangle. That means BE, this is E, BEC. Angle BEC is exactly equal to angle DFC. Why these two angles are equal? Because each value is 90 as they are given perpendicular. Next, third one. I have this angle C in this red triangle. I have this angle C in this black triangle. So I want to mention this angle C. See, like this. Angle BCE. Angle BCE is exactly equal to angle DCF. I am talking about the same common angle. This is the angle in this triangle and in this triangle. So this is the reflexive property. Angle C equal to angle C. That means reflexive property. Now what we proved now, this angle, red angle, and this red angle, and this side, angle side, sorry, this side and this angle, in between two angles one side. In the same way in this black triangle, this angle equal to this angle and this angle and this side. Therefore I can say triangle BEC is congruent to triangle DFC. Why they are congruent? The reason is in between two angles one side. So ASA, congruency rule, I can say, or criteria. So according to this, they are congruent. Now when once we have proved two triangles are congruent, this their corresponding sides. This BC is corresponding to, because BC is opposite to, that is hypotenuse in this right triangle. In the same way, for this right triangle, this is opposite side DC. Therefore, they are congruent because CP, CTC. That means corresponding parts of congruent triangles are congruent. That is the reason. And the sixth one, when once these two sides are equal, therefore I can conclude, therefore ABCD is a rhombus. Why I am concluding like that? The reason is adjacent sides are congruent in a parallelogram. See, parallelogram, this is a symbolic notation. I am using notation form. Symbolically we can represent like this. So I have proved adjacent sides are equal. Therefore ABCD is a rhombus. So now I can conclude, hence proved. I can say hence proved. So that's what I have proved. ABCD is a rhombus. Thank you.